Hello all, this video is a continuation of the previous video. Previous video we have worked with the email spam detection with the different machine learning algorithms, and in this work we are going to work with the decision tree and make a comparison with the different all others machine learning algorithms which we have made. For that we are initially loading the data set. This data set we downloaded from Kaggle. You can just give us a hard email spam detection dataset. Kaggle means you will get this dataset. This dataset is having nearly 3 columns, which is first is the serial number, next is an email text and email type. Then we are getting the info of the dataset. Within the info of the dataset, you may notice that the unnamed one, which is the serial number, is the integer type, and others which are email text and email type or object type. Then we are checking whether our data set is having any null values. If you may notice that within the email text it is having nearly 16 values, and also we have to drop this further. The unnamed column, which is as just the serial number, is not needed, so we can drop that column also. So for that we are using the drop now function and drop duplicate function, and then also we are checking the missing values. By this you may notice that the unnamed entry is removed, and now the null entries within the email text is also removed. And now we are getting the shape of the data. It is having nearly 17,538 entries, and we are making a plot regarding the value counts for the email type. When comparing the value counts of safe email and phishing email, email has many counts when compared to this phishing email. Then we are using the train test split function to split the data into x train, x test, y train, and y test. For that, initially we are declaring the x variable. But within the x variable, we are using the email text, and within the y variable, we are using the email type. Then by use of the testing sizes 0.2, that is 20% for training and remaining 80% for testing, or 20% for testing and remaining 80% for training. We are determining these 4 variables. Then we are the every variables, if you notice, means it is in text type, that is in object type. We have to convert it into vectors. For that we are using the tfidf vectorizer, and this tfidf vectorizer we are applying to the variables like xtrain and xtest. This xtrain and xtest only we will be using in all the machine learning models which we have declared. First we have worked with logistic regression, and we have displayed the predictions, then confusion matrix, and also the classification report. With this logistic regression we have got 96% accuracy. Then we worked with the support vector machine, and we have displayed the predictions, confusion matrix, and also the classification report, and have got an accuracy of 98%. Then we worked with the catboost, and we have displayed the predictions, displayed a confusion matrix, and also displayed the classification report, and has got an accuracy of 97%. Then we worked with the passive aggressive classifier and displayed the predictions, confusion matrix, and classification report, and we have got an 96% accuracy. Then we worked with the random forest, and we have displayed the predictions, the confusion matrix, and the classification report. And for this the random forest we have got an accuracy of 97%. Then we have worked with a multinomial Bayes algorithm and displayed the predictions, confusion matrix, and classification, have got an accuracy of 95%. In this work we are going to work with k neighbors, nearest neighbors. So for that, the nearest neighbors which we have declared is, initially we are declaring the library. Then within this library we are calling within a variable, and within that variable we are declaring neighbors as 7. Then we are training the model by using the fit function and the training variables, and we are testing the model by the predict function and the testing variables. Then we are displaying the predictions within an array. Then we are displaying a confusion matrix. Then you may notice that within, initially the shape of the data set nearly 17,000, but here we are getting only some entries. This is because we are displaying the confusion matrix for the test value only. Test value is using only 20% of the data, so only we are getting less values in the confusion matrix. And within the classification report with KNN we are getting 78%. So this is the least accuracy we have obtained so far. All others we are getting greater than 90 only. So the algorithms which we have implemented so far include logistic regression, support vector machine, catboost, passive aggressive classifier, random forest, naive Bayes and KNN. All this we are going to make within a bar plot, and we have declared the accuracies of every plot. So from this you may notice that this KNN is having the least accuracy and this SVM is having the highest accuracy. So this is the bar plot for that.